Welcome to the video lecture on Q data structure. This is Dr. Sweetie Hemlata from School of Computing Science and Engineering, VIT, Chennai. Here you could see the picture of a queue where people are waiting in a line to get some service which is available at the counter. In the real world, you could see queues in many places. For example, in the supermarket, you could see people waiting in the queue for getting their bills in the billing section. Or else in the hospitals, patients may be waiting in a queue to get an appointment with the doctor. So in this case, if a new person is coming, where he can be inserted in the queue? Obviously it is at the rear end. He can go and stand at the end of the queue. Then what about the person who is standing at the front? So he will get his service done and he will leave the queue. So the person who is standing at the front will be the one to leave the queue next. So queue is a data structure where insertion happens at the rear end and deletion happens at the front end. So here insertion operation is termed as NQ and deletion operation is termed as DQ. So you could see that in a queue, whichever element got inserted first will be the first element to leave the queue. So queue follows first in, first out policy, that is FIFO policy. Coming to queue ADTs, we can have three basic operations like NQ, which takes an element X and insert that element in the queue, and DQ, it takes only one parameter Q because it doesn't require the element to be deleted, because whatever element is available at the front position will be deleted automatically. Similarly, the front also takes only one parameter Q and it returns whatever is available at the front. So let's see how NQ operation happens in Q. So let me start with an empty queue. So here you could see a queue with a maximum capacity of holding 4 elements, and nothing is available initially. Right from first location to the last location means that front is 0, rear is also 0. That is the condition for checking empty queue in the initial case. So now let's try inserting the elements 1, 2, 3, 4 in the queue. That can be done by calling NQ method, passing the respective element and calling the function NQ in a sequential way. So let's see, NQ of Q, 1 means that 1 has to be inserted now. So now since the queue is empty and this is the first element, we increment both rear and front, because whenever you insert you have to keep track of the rear pointer, because at that rear people will come and stand. But since it is the first insertion, the first element that got inserted in the queue is the possible candidate for leaving the queue first. So front is also updated to show this condition. So rear and front both are incremented in all the cases. So inserting 2, inserting 3 and 4, you could see that only a rear is getting incremented, and at that rear location the respective elements are stored. So in all the other cases, you could see front remains the same, that is at the first position. So now you could see that the queue is full, and at this point if there is a call for NQ for inserting another element, that is an error. So error message like queue overflow can be displayed. So now let's see the pseudocode of NQ method. So NQ takes 2 arguments, Q and X. We have to check whether the queue is full or not. If it is full, insertion cannot be done. So its full is checked with is full method. If it is full, can print an error message queue overflow. Otherwise, we check whether it's a first insertion. That can be checked with the front value. Front will be equals -1 initially. So if it is equals -1, increment front also. Otherwise, you increment only rear in all NQ operation, and at that position you place the value X. Now this is the pseudocode for is full. Here we check the full condition of the queue. So how it can be done? We check whether the rear, which gets incremented every time when some element gets inserted in the queue, at one point of time rear will be at the last location, that is the maximum capacity, beyond which rear, if we increment it, is beyond the capacity of the queue. So we check the full condition. If rear is equals maximum capacity, then it is true, otherwise it is false. Now let's see how the pseudocode is mapped to C code for NQ and is full. Now this is the definition of NQ, where you could see two parameters. One thing is a pointer to queue structure. It's a pointer variable, and here you could see X. So before seeing the reason for passing pointer here, let's see the structure of the queue. So what are the elements of the queue? Here we could see the queue is a structure. It's declared as a structure, and the elements of the queue are an array. So here the array name is QUE with a maximum capacity of 10, and another thing is the front and rear variables. Okay, so these are the components of a queue which is available as a structure. So having declared the structure of the queue, let's go back to the definition of NQ function. So here I'm going to modify the variables front and rear associated with a queue. So whenever I do make changes inside a function and I want to have the changes reflected in the calling part, I have to pass the address. So here, while calling NQ, address is passed. So that address is now available in a pointer variable. So now first we check the full condition of the queue by calling the method is full. Okay, so is full, I need to pass only the value, not address. So I just pass the value by using the indirection operator asterisk and the variable name. So if it is full, I just print the error message queue overflow. If it is not full, I am checking the first insertion by checking the value of the front equals -1. You see how I have used this pointer variable and access the member of the structure. Now this is the pointer variable of a structure queue, and since it is a pointer variable, I have to use arrow operator and access any member of the structure. So pointer queue, arrow, and then front equals -1. I increment the front. In all the cases, I just increment the rear. At that incremented value, updated rear value, in the queue array, I place the element X. So you could see how the members of the structure queue is accessed. A pointer, arrow operator, name of the array, and within square, that is the subscript, I mention the rear, which is again a member of the structure. So again we have to use pointer variable, then arrow operator, then member. So this is the index of the array queue. At this point I place X. So now coming to the definition of is full. For is full, you could see only the variable is passed, not the address. So how to check the is full condition? As I told you, rear should be equals maximum capacity, but in C, array index starts from 0 and goes up to n minus 1 in case array has n elements. So here we check instead of maximum capacity, we check maximum capacity minus 1. That is the last location in the array. So if the rear is equals max capacity, then return 1, otherwise return 0. Here you could see since the variable is an ordinary variable, the structure variable is an ordinary variable, I have used variable name dot operator to access any member of the structure Q. Now let's go back to the presentation. So now let's see the dequeue operation. Let me start with the full queue condition where the rear is at the last position and nothing has been deleted, so front is at the first position. So now let us call dequeue method. When I call dequeue method, first element will go out of the queue and the second will be standing at the front. So front is incremented to show this change. So the active elements are the elements from front to rear. Those are the active elements which are available at this time. And the next dequeue operation again does the same. Like front is incremented because 2 leaves the queue, so 3 will be standing in the front. Next operation, 3 leaves the queue, 4 will be standing in the front. So you could see that both front and rear are here same. So now the next dequeue operation, 4 also leaves the queue, front is incremented, it moves beyond the rear. That is this point, let's see that front crosses rear value. This can be checked for empty queue. So at this point, when all the elements are deleted, the queue is actually empty. If I call dequeue, it is queue underflow. It's an error. Now let's see the pseudocode of dequeue. So we have to check whether the queue is empty. That can be checked with the queueEmpty method. If it is empty, then it is an error, queue underflow. Otherwise, we just increment front for every call of dequeue. Then queueEmpty method, how do we check the empty condition of the queue? So initial condition of the queue is front and rear will be equal 0. Later, after deletion, we arrived at a situation that front is greater than rear. In both the cases, in either cases, queue is empty. So it returns true in that case, otherwise false. So the next function is front. So for front is going to return the front element if the queue is not empty. So here also we have to check whether the queue is empty or not. So if it is empty, we have the error again, underflow. Otherwise, we return the value whatever is available at the front. Now let's see how to map the pseudocode to code in C. So here we have the pseudocode for code for dequeue operation, which takes only one argument. Here in dequeue operation also, the members of queue, that is components of queue, this front is going to get updated. So I need to pass the address of the variable which is now available in a pointer variable. Now I check whether queue is empty or not, for which I don't need the address, I just need the value. So the value present in the address can be accessed using indirection operator as I told before. So this is an indirection operator and the pointer variable. If the queue is empty, error message queue underflow is displayed. Otherwise, we just increment the front for every call of dequeue. Then is empty. Here you could see only the variable of structure kind is passed. So here I'm checking. This is the initial condition for empty queue, where both the front and rear will be -1. Later, after deletion, front value may be crossing rear, that is front will be greater than rear. So in these cases return 1, otherwise return 0. Now here is the definition of front. We have a front method which returns the element available at the front. So return type is integer, and we have only one parameter here. Here also there is no need to pass the address. So here you could see that whenever you pass some value, when it value gets updated, then you have to pass the address. Otherwise it's enough to pass just the name, which can get copied to some other variable, and you can do the operation in that. So here also front doesn't involve any change, so just a variable of type struct queue is passed. So again here also I check the empty condition. If the queue is empty, I'm returning -1 to indicate that queue is empty. Otherwise I return whatever is available at the front. So as I told before, so here we have the array name is QUE. It's a member of the structure. So how to access? It's a variable name, dot operator, member name. It is an array. I have to specify the index. The index is front. Again, front is a member of queue, so again it has to be accessed with the structure variable name dot member name. Okay, now we can check the status of the queue by calling display function. Again in display also there is no change, so I can go with the ordinary variable. And here again in display I check the empty condition, because nothing, if nothing is there, there is no display here. So we have to check is empty, and if it is empty, again print the queue underflow error message. Otherwise we can print the elements of the queue. The active element, as I told, they are available from the front position to the rear position, so you can print the elements in the queue. So having seen the function definition, let's go back and see the main function. Here you could see I've declared a structure variable, and then other variables required in the program, and here you could see all the function declaration with that we call it as prototype. And here is the empty queue condition, initialization of empty queue condition, where the front as well as the rear, they are initialized to -1. Here comes the options for the user to do different operations discussed so far, and you get the choice of the user in the variable ch, and it's a multi-way branching switch statement is used to map the choice to different cases. So case 1 is for enqueue operation, so you get the value for value to be inserted in the queue, and call the function by passing the address of the queue and the value. So enqueue takes two. First one is the address and the next one is the value. And in case 2 is for deletion dequeue operation, it takes only the address of the queue. And in the third option is for front. So front takes only the variable, no need to pass the address, and it returns some value. So that return value is available in front value, in the variable front value. So if the return value is equals -1, means that it's an empty queue. So we have to print queue underflow. Otherwise whatever is available the front can be printed, which is available in the front value. The final option is display. Here also we just pass the variable, not the address. So since it is the last case, whether you have break or not, it's not going to make any difference. and this enter option is going to be in the loop as long as the choice is less than or equal to 4. So let's see running this program. So we have the options listed here. So I go with the NQ operation. I give the value as 10. Again one more NQ 20, another NQ 30. Now let's check the front element. After 3 elements being inserted into the queue, who will be standing at the front? So what element is available at the front? So obviously we inserted 10 as the front, so we have to get 10 as the answer. So here you could see the front value is 10. So now let's see the dequeue. So by calling dequeue method with option 2, so after dequeue 10 would have left the queue, so that can be checked with the front. Now the current front will be 20 because 10 has left. Now again dequeue, again 20 is deleted, so front will be 30. Again dequeue, so 30 is also deleted. Now the front, there is nothing in the queue, so front is giving you the error message queue underflow. At this stage, if you give dequeue also, you will get queue underflow. Similarly, you can check for full condition of the queue. So I hope you would have understood the concept of queue data structure, the pseudocode of different operations in queue, and how to map pseudocode to an implementation in C for array implementation of queue data structure. Thank you.